Okay, second video. This one I'm going to make a little bit shorter because I'm not going to go through all the prep work at the beginning to set you up for it. This one is going to be rule number 6. And I'm following my last video, if you haven't watched that one, which was the product rule. This one is going to be about the quotient rule. So this would be the same the reason for this rule is the same reason that we have for the product rule, where if you multiply two functions, you can't just take the derivative of each and then multiply their derivatives. And we could have done an example with two functions being divided by each other. I'm going to skip the example. You're welcome to try one on your own and sort of test it out for yourself, and I'm just going to jump straight to the rule because I think you're probably sick of listening to me talk at this point. Again, we're going to write it two different ways. So when I have some function f being divided by some function g, my derivative ends up being, this one is a fraction, so be careful. There's quite a bit to write here. Stick with me. It's going to be your denominator function times your derivative of your numerator minus your numerator function times your derivative of your denominator, all over your denominator function squared. That's a lot. Okay, there's a couple things I want to point out here. First thing I want to point out is that you're subtracting your two things here in the numerator. So the order does matter. Essentially with the product rule, you can switch things around. So if you don't like the order that I did it in, you can totally switch it up. Second thing I want to point out is that we have our actual functions here, g, f, and g. Those are not derivatives. Those are just functions. Here's my derivatives, f prime and g prime. So again, you have that combination of things going on. Okay, one more time. This time I'm going to write it with u's and v's. And this is just because it's another common way of seeing it. And I think it's good for you to see things in different ways. So, oops. Let's erase that. And let's go back to my blue color. Okay, so we've got derivative of some function u divided by some function v. And it just might look a little bit simpler because we don't have all the x's there in terms of f of x and g of x. So derivative, following my same pattern from before, would be denominator times derivative of numerator, du dx, minus numerator, which is the function u, times derivative of the denominator, which is dv dx, all over denominator squared, which is v squared. And just remember, u and v are not just variables, they are actual functions. And in this case, here's our derivatives right here and right there. The rest are just functions. That should be good on the rule, but of course we need to see that it works. So let's go ahead and do an example. I should say at this point, if you want to flip over to Schoology and pause the video and watch or listen to the song, there is a musical song for this one as well. I know you're waiting for it. It's called the Quotient Rule. Okay, for your example, function. Let's consider the rational function f of x equals x squared minus 1. Oh, come on. All over x squared plus 1. I know some of you are just wanting to simplify that. This is a good chance to review our algebra. We cannot just cancel the x squareds there. We could try factoring. Numerator would factor into x plus 1 times x minus 1. Denominator does not factor. So there is no way to simplify this function as is, just in case that was bothering you. Let's jump into finding the derivative. Okay, so my f prime, and I like to talk myself through this the way I did before. I'm going to continue talking myself through it. Denominator, which is x squared plus 1, times derivative of the numerator, and again I'm writing that out as d dx, meaning I haven't actually taken the derivative yet, minus numerator times the derivative of the denominator all over the denominator squared, x squared plus 1 squared. I'm going to not multiply out the denominator. I repeat, I am leaving the denominator alone. We are not going to waste time on a whole bunch of algebra here. We're just going to do the numerator, figure out what can cancel, and then leave it alone. So I'm going to have x squared plus 1, not changing that. And then I'm going to actually evaluate the derivative of the numerator, which comes out to be 2x minus 0, because the derivative of a constant is 0, minus x squared minus 1, leaving that alone. And now to my other derivative, which also ends up being 2x here, since derivative of x squared is 2x, derivative of 1 is 0. Not touching the denominator. So basically I do have some terms that probably will combine in the numerator, and the only reason I can't combine them yet is because I've got to do some multiplication over here, some multiplication over here. So I'm going to go ahead and do that just so I can simplify that. Again, denominator I'm going to leave just as is. It's beautiful. So I'm going to end up with 2x cubed plus 2x, it looks like, minus, I'm going to try to do this all at once. I'm taking the negative 2x is what I'm thinking of it as. I'm putting the 2x in front and distributing that through x squared minus 1. So that's going to give me a negative 2x cubed, and then minus a negative is going to be plus a positive 2x. If you need to do another step there, go ahead and do that. All over x squared plus 1 quantity squared in the denominator. And I'm almost done here. Simplify that up. It looks like I have a 2x cubed and a negative 2x cubed. That's not always going to happen, but in this case, they're going to cancel. Let's get rid of those, and I have a plus 2x and another 2x. So really my answer ends up being 4x over x squared plus 1 quantity squared. Again, we're not going to multiply things out. We're going to call that our final answer right there. If you wanted to take a second and check, this would be a good one to check in our GeoGebra file that we were playing around with the other day. You're welcome to do that. Type in the function and then have it tell you the derivative, and it should be telling you this. So you're welcome to take a minute and do that. I'm going to leave it at that because I don't think you probably need another example. It's just going to be a matter of plugging in your formula, so to speak. I am going to make one additional video that has a more complicated example, and we're going to kind of look at what ruler we're going to use and why.